a scalding volcano, parched desert, and frigid glacier. All pretty intense, and also all places where certain insects live. So, how do they do it? Our first stop is one of the hottest places on Earth, the Sahara Desert. Lots of animals here are only active at night, but not all. Sahara silver ant workers brave the desert's blazing sun and scorching sands with unusually long legs that elevate their bodies above the hot ground and allow them to reach superlative speeds. They can sprint a meter per second, each of their feet striking the sand for as little as 7 milliseconds at once, making them the fastest ants on record. But the reason for their silver sheen is also key to keeping cool. The ants are covered in densely packed hair. Instead of having a heat-trapping effect, the hair's triangular structure reflects sunlight and dissipates heat. Researchers observed that it helps reflect 10 times more incoming light and keeps the ants around 10 degrees cooler than if they were hairless. Meanwhile, this longhorn beetle also sports triangular hairs that give it a metallic shimmer and cool it down. Helpful, since it resides near active Thai and Indonesian volcanoes where ground temperatures can reach 70 degrees Celsius. Many insects thrive in balmy biomes, but cold temperatures, like those looming over this ice-laden landscape, are a major constraint on insect life. And yet, certain insects actually depend on these cool climates year-round. One small group, sometimes called ice crawlers, lives in high-elevation caves and at the edges of glaciers. They've evolved to thrive in a narrow zone of cool temperatures. Scientists think one way they manage this is their increased capacity to produce a type of sugar that helps stabilize their cell membranes, proteins, and DNA. But they've lost the ability to deal with temperature extremes. For instance, just the heat of your hand could kill them, given enough time. Now, for a more savory flavor of survival skills, we have the alkali fly. They live around and in California's Mono Lake, which is more than twice as salty as the ocean. As aquatic larvae, they depend on specialized kidney-like organs to excrete excess salt. And as adults, they must continue to venture underwater regularly to eat and lay eggs. However, at their size, overcoming the water's surface tension and staying submerged is a challenge. They manage to exert forces up to 18 times their weight to break the surface tension, then use their claws to counteract their buoyancy in the salty water and stay put down below. Because their bodies are covered in more hair and hydrophobic wax than other flies, they're surrounded by an air bubble that keeps them dry and provides them with up to 15 minutes of oxygen. When they release their hold, they pop right back up to the surface, perfectly dry. However, only one insect group is known to actually withstand the ocean's depths. These are parasitic lice, and they live on deep-sea diving pinnipeds like seals and walruses. Their plunges can take the lice thousands of meters underwater for extended periods. Most insects use holes on the sides of their abdomens called spiracles to take in oxygen. Interestingly, these lice are equipped with microscopic structures that allow them to shut their spiracles entirely. Scientists think this may help them keep air inside or prevent water from entering, allowing them to survive long periods submerged in high-pressure conditions. Some lice may also attain oxygen by living on seals whose fur traps air close to their bodies. Meanwhile, lice on marine mammals with less hair seem to have more scale-like structures on their abdomens, which might help them trap a little layer of air all for themselves. Insects are the world's most numerous and diverse animals. Even in some of the places you might least expect them, there they are, equipped with extreme survival skills, living life on the edge. Now, meet the tardigrade, one of the toughest species on Earth, able to survive its hottest and coldest environments, go without water for decades, and withstand high levels of radiation. How do they do it? Learn more with this video.